In this video, I'm going to solve the questions in Unit 3 test. The first question was the equation of asymptote for the function y equal 3x times 5 exponent x plus 2. When x goes to negative infinity, 5 exponent negative infinity is 0, so y is equal to 2. Or you can just look at the constant here, which is 2. So the answer to this multiple choice is A. The next question is question number 2, which says the exponential function y equal to 3 times 1 over 3 exponent x plus 6. I can write this exponential equation as y is equal to 3 times 3 exponent negative 3x plus 6, which the same way I can write it as 3 exponent negative 3 times x plus 0 plus 6. If you look at the absolute values, negative 3 is 3, which means that the function is compressed horizontally by a factor of 1 over 3, and the 3 here tells us that it's stretched vertically along the y-axis. So the correct answer is A and B, which is going to be D. The next question says graph y equal to 2 exponent 3x minus 9 plus 8. Again, I can write this equation as y is equal to 2 exponent factor of 3x minus 3 plus 8, and as you can see from negative 3 here, it has been moved 3 units to the right. So the answer is C here. As I mentioned in the test, there was a typing mistake here. This one is really 5 minutes. So we have bacteria which doubles every 5 minutes. And the question is that which of the following is going to be correct representation of this growth. And as you can see, there is a doubling here, so this one and this one, because these are talking about getting halves, but we are doubling here, so it's either C or D, but the doubling time is 5 minutes, so this means the correct answer is X over 5. Question number 5 says, this is an example of, as you can see, it's doubling, so it's going to be exponential growth, which is going to be A. Question number 6, graph of y equal 3 exponent x and y equal negative 3 exponent x are reflection of each other on the y-axis, which is incorrect because these are reflection on the x-axis. So the answer to this part is going to be false. The next question, question number 7, it says that the first difference of an exponential function is constant, which is incorrect. It's the ratio, which is going to be the same, which is constant. So the answer to this one is also false. Question number 8 says for exponential function y equal 8 exponent x, when x goes to negative infinity, y goes to 0. When x goes to negative infinity, y becomes 8 exponent negative infinity, which is the same as y is equal to 1 over 8 exponent infinity. 8 exponent infinity is infinity, 1 over infinity is going to be 0, so this is true. As x goes to negative infinity, y goes to 0, so this is true. Question number 9 says the exponential function y equal negative 2 exponent 3x has y-intercept 0, and the answer is incorrect because for y-intercept I have to set x equal to 0, so I get y is equal to negative 2 exponent 3 times 0 is 0, which is going to give you negative 1, so the answer is false. For question number 10, half-life is the amount of time it takes for a sample to reduce to 50% of its original size, which is correct, so the answer is true. And the equation of P of t is equal to 3 times 2 exponent t represented tripling, which is incorrect because if you can see the base is 2, so this is really a doubling of bacteria. So the answer is false. Question number 14, part A, asks us to simplify and evaluate where possible, and we have to express all the answers using only positive exponents. So first I am going to change everything to its base and exponents. 16 can be written as 2 exponent 4 times x exponent 4 exponent 3 over 2. 27 can be written as 3 exponent 3 x exponent 3 1 over 3. Now when you have power to power, you are going to multiply exponents. So here we will have 2 exponent 4 exponent 3 over 2. I'm going to distribute 3 over 2 and 1 over 3 inside. I get 2 exponent 4 times 3 is going to give me 12 divided by 2 is going to give me 6. So it's going to be 2 exponent 6. X exponent the same, 6 times 3 times 1 over 3 gives me 1. So x, for x and also for 3, I'm going to get the same thing. Now 2 exponent 6 times 3 is going to give me 192. And x exponent 6 times x is going to give me x exponent 7. For part B, I'm going to simplify the constants. 24 divided by negative 2 gives me negative 12. C exponent 3 divided by C exponent 7, remember you subtract the exponents, becomes C exponent 3 minus 7, which is minus 4. D exponent negative 7 divided by D exponent 5 gives me negative 7 minus 5 is D exponent negative 12. Now, because it says that all exponents they have to be expressed in positive, I'm going to have negative 12 divided by C exponent negative 4. I'm going to flip it and the exponent becomes positive, and D exponent negative 12, if you flip it, it becomes positive. So the answer becomes negative 12 C exponent 4 D exponent 12. The next example or question is asking to evaluate each one of these expressions. The first one is 8 exponent 1 over 3 minus 32 exponent 4 over 5. Again, I'm going to express 8 and 32 as base and exponent. So I'm going to write 8 as 2 exponent 3 and then exponent 1 over 3 minus 32 is 2 exponent 5 exponent 4 over 5. Again, I'm going to distribute 1 over 3 and 4 over 5 inside the bracket. Power of power, we are going to multiply the exponents, so 3 times 1 over 3 is going to give me 1 minus 5 over 5, again 5 times 4 over 5 is going to give me 20 over 5, which is 4, so it's going to be 2 exponent 4, but 2 exponent 1 is 2, 2 exponent 4 is 16, so 2 minus 16 is going to give me negative 14. Now for part B, I'm going to express again each part of the fraction into base and exponent. I'm going to write this one as negative 27 is 3 exponent 3, and 8 is 2 exponent 3, exponent negative 2 over 3. This one can be written as negative 3 over 2, exponent 3, and the whole thing is exponent negative 2 over 3. Now, when you have power to power, we are going to multiply the exponents, so this really becomes negative 3 over 2, and 3 multiplied by negative 2 over 3 is going to give me negative 2. When you have negative exponents, I can flip the fraction and change it to positive, so this becomes negative 2 over 3 exponent 2, and then negative 2 over 3 exponent 2 is the same as negative 2 over 3 times negative 2 over 3, which is going to be 4 over 9. The next question is about solving exponential equations. The first one, 63 times 3 exponent 4 minus 3x is equal to 7. So the first thing I'm going to do is that I'm going to divide both sides by 63. So I'm going to get 3 exponent 4 exponent negative 3x is equal to 7 over 63, which is going to be 1 over 9, which is really 1 over 3 exponent 2, which is 3 exponent negative 2. Now, when the bases are equal and the powers are the same, so the exponents, they have to be the same. So 4 minus 3x is negative 2. I move 4 to the right, I get negative 3x is equal to negative 2 minus 4 is negative 6. Divide by negative 3, I get x is equal to 2. The next question is 8 exponent 3x minus 2 is equal to 16 exponent x plus 4. I'm going to represent 8 as 2 exponent 3 exponent 3x minus 2 is equal to 16 is 2 exponent 4 x plus 1. Now I can multiply exponents power to power, so I get 2 exponent 3 times 3x minus 2 is 2 exponent 4 times x plus 1. Now when the powers are the same, when the bases are also the same, then it means that the exponents, they have to be the same. So this means 3 times 3x minus 2 has to be equal to 4 times x plus 1. If you distribute the constants inside, we get 9x minus 6 is equal to 4x plus 4. I move negative 6 to the right, 4x to the left. I get negative 9x minus 4x is 5x. And negative 6 becomes positive 6. 6 plus 4 becomes 10. Divide by 5. And we get x is equal to 2. The next question is the function y equal negative 1.5 3 exponent negative x minus 1 minus 1. We are supposed to graph by determining the base function, mapping notation, and table of values. Now, if we look at this function, the base function is very simple. It's going to be y equal 3 exponent x. This is our base function. Now the mapping function or notation, first we have to change the notation of the function y. So I'm going to write y is equal to negative 1.5 open bracket 3 exponent. I'm going to take the negative 1, factor it out, so I'm going to get negative x plus 1 close bracket minus 1. So from this notation, first of all, I can see that every x value is multiplied by negative 1 because of the reflection, and also every x value is subtracted by 1 because here we have addition. So I can write the mapping notation as x comma y goes to x is multiplied by -1, so it's negative x, and then subtracted 1, so negative x minus 1. Now, if we look at the y is multiplied by negative 1.5 and also subtracted by 1. So my y becomes negative 1.5 y subtracted 1 from it. So this is my mapping notation. Now for table of values, I'm going to draw two table of values, one for the base function, and the values that I'm going to choose are 0, 1, 2, let's say, and 3 and 4. For the base function, which is y equal 3 exponent x, if x is 0, then 3 exponent 0 is 1. When x is 1, 3 exponent 1 is 3. When x is 2, 3 exponent 2 is 9. When x is 3, 3 exponent 3 is 27. When x is 4, 3 exponent 4 is going to give me 81. For the transform function, I'm going to do exactly the same, but this time I'm going to use the mapping notation applied on the base function's table of values. The base function table of value is on the left. So when x is 0, we are going to apply the mapping notation minus x minus 1. So minus 0 minus 1 is going to give me minus 1. When x is 1, minus 1 minus 1 is minus 2. When x is 2, minus 2 minus 1 is minus 3. When x is 3, minus 3 minus 1 is minus 4. And when x is 4, then minus 4 minus 1 is minus 5. Now I'm going to apply the same mapping notation on the y coordinate. When y is 1, negative 1.5 times 1 minus 1 is going to give me negative 2.5. When y is 3, which is here, negative 1.5 times 3 minus 1 is going to give me negative 5.5. When y is 9, negative 1.5 times 9 minus 1 is going to give me negative 14.5. When y is 27, negative 1.5 times 27 minus 1 is going to give me negative 41.5. And when y is 81, negative 1.5 times 81 minus 1 is going to give me negative 122.5. Now I'm going to use each table of value and plot roughly the graph of the two functions. For the base function, this table of value, when x is 0, y is 1. When x is 0, y is 1. This represents the y-intercept. When x is 1, y is 3. When x is 1, y is 3. So it's going to be somewhere around here. When x is 2, y is 9. When x is 2, y is 9. So it's going to be a point about here. And that's probably enough because the other 2 points are going to be off the grid. And also when x goes to negative infinity, 3 exponent negative infinity becomes almost 0, which represent line y equals 0 to be our horizontal asymptote. So the graph approximately becomes something like one which I just drew on the graph. Now for the transformed function, the table of value is this one, and I'm going to go ahead and plot the graph. When x is negative 1, y is negative 2.5, so it's going to be somewhere around this point, approximately. When x is negative 2, y is negative 5.5, so negative 2 is 5.5, so it's going to be 2, 4, 5, 5.5, which is going to be approximately here. When x is negative 3, is negative 14.5, so negative 3 is going to be somewhere around here. Now, the 2 points are going to be off the grid. There is another point that I'm going to consider is when x goes to positive infinity, negative x minus 1 becomes negative infinity minus 1, which is negative infinity. 3 exponent negative infinity becomes 0. Negative 1.5 times 0 is 0, and y becomes negative 1. So this means that this line, y equal to negative 1, is going to be our horizontal asymptote. So the graph which is going to look something like the following, roughly. Now the second part of the question says, state the y-intercept and equation of the asymptote. The y-intercept is when x is equal to 0. So if I substitute x equal to 0, I get y is equal to negative 1.5 times 3 exponent. Negative 0 is 0, negative 1, minus 1. And this one, when you simplify it, you are going to get negative 1.5. Now, and the equation of the horizontal asymptote is, as I said when plotting the graph, when x goes to infinity, then y becomes negative 1.5 times 3 exponent. Negative infinity minus 1 is negative infinity minus 1. 3 exponent negative infinity gives me 0. And equation, this one becomes negative 1. So we can say the horizontal asymptote is y equal negative 1. The third part of the question says, state the domain and the range of the transformed function. If you look at the graph, which is here, you can see that there is no restriction on the x value, so I can say safely that D, or the domain, is x in R. All the real values are acceptable. But for the range, you can see that the y values are all less than negative 1, but they never equal to negative 1, because y equal negative 1 is the horizontal asymptote. So I can say that range is y in R and y less than negative 1. The last part of the question asks, is the function increasing or decreasing? As I mentioned in the class, the easiest way to find out the answer is to start walking on the graph from left to right. So if you start walking on the graph from left to right, x is going to increase because you are going to the right. And at the same time, when x is increasing, y is also increasing because you are going up on the graph. So this means y is also increasing. So this, since x is increasing, y is increasing, then we say that the function is increasing. The next question is about the car, which the initial value of the car is 35,000, and the resale value depreciates or decreases by 10% of its value. The equation is given by this formula. V of t is 35,000 times 0.9 exponent t. First, we are supposed to explain the significance of each part of the equation. 35,000 is the initial value. 0.9 is the decay factor. Okay, this one represents how much the value of the car is depreciating every year, and t represents the time here, which is represented in years. The next question says how much the car will worth after 8 years. So I have to evaluate the function v of t at 8. So I'm going to say v of 8 is 35,000 times 0.9 exponent 8. If you simplify this one, you're going to get about $15,066.35. So after 8 years, the car which was worth at 35,000 is going to worth about $15,000. The next part of the questions ask, how long would it take for the car to depreciate to half of its value? Now, as I said, there was another typing mistake. This is not really half, this is 20%, so forget about the half here. So we have to find the time that it takes for the car to depreciate to 20% of its original price. So I have to solve above equation if the price becomes 0.2, because 20% is 20 divided by 100, which is 0.2 times 35,000. I have to find time here. So this is the equation that I have to solve. Now I can cross out 35,000, so I get 0.2 is equal to 0.9 t. To solve this one, I take the log of both sides, so I get log 0.2 is t log 0.9. I divide by log 0.9, so I get t is log 0.2 divided by log 0.9. If you use your calculator and simplify this one, then you get something about 15.28 years. Something between 15 and 16 years. The next question is asking, are the functions f of x equal 3 exponent negative 2x and g of x equal 1 over 9 exponent x identical? And explain. I'm going to simplify f of x, which is 3 exponent negative 2x, as 3 exponent negative 2 exponent x. Remember, power to power is just multiply the exponent. 3 exponent negative 2 is really 1 over 3 exponent 2 exponent x, which is going to be 1 over 9 exponent x. Then I can distribute x as exponent inside, so I'm going to multiply exponents. 1 is the same as 1 exponent 1, so 1 times x is going to give me 1 again, and this one becomes 9 exponent x, which is identical to g of x. So that's why these two graphs, they represent the same functions. The next example asks to write the function f of x equal to 4 exponent x after the transformation g of x. If you look at the transformation, it says replace the x in f with negative 4x. So I get 4 exponent, instead of x is negative 4x. Then multiply f, which is 4 exponent negative 4x, by negative 4, which is here. So I multiply this guy by negative 4, and then subtract 4 from it. So I get this equation. I can also simplify this one, because 4 times 4 exponent negative 4 exponent negative 4x is the same as negative 4 exponent. This is exponent 1, so you can add it. So negative 4x plus 1, negative 4. So this is the equation of the transformed function, g of x. The last equation is to find x and y if we have these two relationships. First, I'm going to simplify this one. 16 I can write as 2 exponent 4. So I can write 2 exponent 4 exponent x plus 2y divided by 8 I can write as 2 exponent 3 exponent x minus y is equal to 32 is 2 exponent 5. This one is when we simplify this. Now, power to power, I multiply the exponents, so I get 2 exponent 4 times x plus 2y divided by 2 exponent 3 times x minus y is 2 exponent 5. Now, when you have division of powers, when the bases are the same, we subtract exponents, so we get 2 exponent 4 times x plus 2y minus 3 times x minus y is 2 exponent 5. Since the bases are the same, the exponents, they have to be the same, so I'm going to get 4 times x plus 2y minus 3 times x minus y is equal to 5. If I distribute negative 3 and 4 inside the bracket and simplify, I get 4x plus 8y minus 3x plus 3y, and then I just going to leave 5 on the right, equal to 5. 4x minus 3x gives me x. 8y, 3y gives me 11. So the first equation becomes, when simplified, to x plus 11y is equal to 5. Now we are going to go ahead and simplify the second equation, which is this one. Now for the second equation, I'm going to go ahead and do the same thing. I'm going to represent 32 and 16 as base, exponents with base 2, and also 1 over 8. I can express it as exponent with base 2. So 32 is going to be 2 exponent 5. So I'm going to write this one as 2 exponent 5 exponent x plus 3y divided by 2 exponent 4, which is 16, exponent x plus 2y is over 1 over 2 exponent 3. Now, because we have power to power again, we're going to multiply exponent, so I can get 2 exponent 5 x plus 3y divided by 2 exponent 4 x plus 2y is equal to, this one I can just flip and change the sign of the exponent. Now when you have division of powers with the same base, I'm going to subtract the exponent, so I'm going to get 2 exponent 5 times x plus 3y minus 4 times x plus 2y is equal to 2 exponent negative 3. Since the bases are the same, the exponents, they have to be the same. So from here I can get 5 times x plus 3y minus 4 times x plus 2y has to be equal to negative 3. Now I'm going to distribute 5 and negative 4 inside the bracket and simplify. I get 5x plus 15y minus 4x minus 8y is equal to negative 3. 5x and negative 4x gives me x. 15y and negative 8y is going to give me 7y is equal to negative 3. Now I have this equation and the previous equation. So I have a system of linear equations and I can go ahead and solve them with either elimination or substitution. Okay, so I decide to use elimination, which seems to be simple enough. Now, since x in both equations, they have the same coefficient, I'm going to subtract equation 2 from equation 1. So I'm going to change the sign here to opposite, and then I'm going to add. X minus x gives me 0. 11 minus 7y gives me 4y. And 5 plus 3 gives me 8. Divide by 4. So from here I get y is equal to 2. Now I'm going to use either one of these equations here, sub y equal to 2 and find x. So I pick the first equation, I say x plus 11 times 2 is equal to 5. Now 11 times 2 is going to give me 22. I move it to the right, it becomes negative, so x is 5 minus 22, which is going to be negative 17. So I say x is negative 17. So our POI is going to be negative 17 and 2.